Notice there are lines underneath each equation. That's to help keep your work orderly and neat. Oftentimes, when you have lines like this, they can be used as hints for about how many steps or how many sentences or how much you should write. In this case, not so much. I did my best to pick a good number of lines for each row, but I only had so much space, and if I added more lines, the paper would have been too close together. So, just know that there will be problems with more lines than necessary, and there will be some where you might need to use some scrap paper or be creative with how you fit the whole thing on. But keep that in mind and remember that on this particular assignment, the lines are not necessarily hints for how much work needs to be done. It's time to do some serious multi-step equations. On this page, we are bringing it all home with all sorts of different varieties of equations. There are 30 of these. We'll do over a third of them together, and then you'll do the rest on your own. I'm doing an example of each type, and so I hope that will get you through the rest of them. I want to make sure that you can do all of these. And so far we've done 1 and 2 steps in the context of these videos. This has got more than 2 steps, but it's got steps that you should be very well aware of doing. Like, for example, you'll have to combine all the terms first. And that's an extra step that we haven't been doing in the context of these videos. We've done them elsewhere. Got my scrap paper just in case I need it. Let us begin with number 1. The first thing that we want to do is to get the variable term by itself. Here's our variable term. Since it's minus, I'm circling it to make sure that I don't forget to keep that minus with the variable term. The common reason people miss questions with algebras, they forget those negatives. That is really common. That and then misreading their handwriting. To get that by itself, I need to get rid of the 6, and it's positive, so I'll subtract 6 from both sides. Minus 6 minus 6. That cancels out, so now I have negative 8x equals 24. Now that I have the variable term by itself, I want to get just the variable. I have a negative 8 with the variable, so I'm going to divide both sides by negative 8. When I do that, the negative 8 cancels out, and I'm left with x equals, this is positive divided by a negative, so my quotient is negative 3. Number 2. I have a variable term on both sides, and I have constants on both sides. I need to get it so that all the variable terms on one side and all the constants are the other. I'm going to start with making sure I've got all the variable terms on the left side. To get rid of the variable term on the right side, I'll do the opposite. The opposite of minus 3y is plus 3y. So I'm going to add 3y to both sides. That cancels out, and I have 11y minus 9 equals 2. 11y minus 9 equals 2. Now this is much simpler. I want to get the 11y now that I have all the variable terms to consolidate it on the left. Now I just need to isolate them, and I need to get rid of the negative 9. I'll do that by adding 9 to both sides, plus 9 plus 9. So that gives me 11y equals 11. Now to isolate just the variable. I'll divide both sides by 11. That cancels out. Y equals 1, because 11 divided by 11 is 1. Number 3. Goodness. I've got variable terms on both sides and constants on both sides, but I've got 2 constants over here and 2 variables over here. So I can't do anything nothing at all until I first combine all the like terms. That's got to be done first, and then I can start moving things around. So let's do that first. The first step since I've got two constants over here, I'll combine them. But because it's better to do the variable term and then the constant term, I'm going to do that first. You don't have to do it that way, especially in the process of solving. Your answer needs to be that way. However, it's just good practice and it's more organized and you can move things around, but I don't know. I like to keep it in a set order. So I have negative 4x, 7 plus 3 plus 10 equals, got x minus 3x. That's negative 2x minus 16. All right, now I'm in the same place that I was when I started up there. I have variable terms and constant terms on both sides. So I'll start by getting rid of the variable term on the right side because I don't want it on the right, I want them all on the left. The opposite of minus 2x is plus 2x. So I will add 2x to both sides. Hope I have enough lines on this one. So now I have negative 2x plus 10 equals negative 16. Now, I'm ready to isolate this variable term. I need to get the constant on this side. The opposite of plus 10 is minus 10. That gives me negative 2x equals negative 26. That's a lot. All right, so now I need to isolate just the x. So I'll do the opposite of times negative 2. I'll divide by negative 2. X equals negative 26 divided by negative 2 is positive 13. Okay, so got that. Let's proceed to do the next set. Number 4. All right, 4. I have to, should I distribute or not? I think for the sake of the fact that there's all this stuff going on, I feel like, I feel like I'm just going to go ahead and distribute this out and just write it that way. There's too much going on to see whether it would be easier to divide and stuff. So I'm going to go ahead and distribute this out. Negative 5x minus 18 equals 6 times 1 is 6 minus 6 times 2x is 12x plus 4. Okay, so now I can combine like terms. I really worry about having enough space on this one. Let's see. I'm going to maybe consolidate, make these small on this side. All right, so these are already all combined. I'm going to make this a little bit smaller in case I need to use this half for another set of steps. Negative 5x minus 18 equals, okay, I've got negative 12x. Then I have 6 plus 4 plus 10. Now I'm going to get all of the variable terms to the left. So to get rid of it from the right, I need to do the opposite. So I will add 12x to both sides plus 12x. That gives me 7x minus 18 equals 10. Next priority is to get the variable term by itself. To get rid of the minus 18, I need to add 18 to both sides. that gives me, I'm going to write it down here, 7x equals 28. Now I'm going to come back over here. I'm going to take this and write it over here. 7x equals 28 there. That way it's neat. Okay, so now to get the x all by itself, I'm going to divide by 7. That gives me x equals 4. There, see, I made it work. Number 5, 50. 4 times x is 4x. I should do the plus. 4 times negative 2 is negative 8. Equals 105 times 2 is 210. Now we've got, let's see, we've got only a constant over here. We've got variable term, and then we've got 2 constants. But I need to combine these first. So, okay, so the next thing I need to do is I need to make sure I've got all my like terms combined. So I'll start with 4x. Then I've got 50 minus 8 is 42. Equals 210. All right, so now I have to isolate the variable term, so I will subtract 42 from both sides. That gives me 4x equals, you know what, I'm going to subtract it right here. I've got 168. I'm going to write that just a little bit neater. 168. Let me isolate the x, so I will divide both sides by 4. X equals 168 divided by 4. I'm going to do this in my head, is 42. Just because I'm doing it in my head does not mean you need to do them in your head. If you get to situations like this, then you need to divide it out. Divide it out. It's okay. I'm mostly doing it to save time. Down we go. Number 6, n divided by 3 plus 8.3 equals 29.3. So let's see, we've got, here's my variable term, then I've got a constant on this side, and then just a constant on that side. That means that I need to isolate just my variable term first. I'll subtract that to get rid of it. Minus 8.3 minus 8.3. That leaves me with n divided by 3 equals 3 minus 3 is 0. 29 minus 8 is 21. Got 21.0 or just 21. I need to get the variable just by itself, and right now I'm dividing by 3. So I'll do the opposite of dividing by 3, and I will multiply by 3. That leaves me with n on this side. 21 times 3 is 63. Okay, number 7. We've got, we've had the combined like terms, we've had distribution, we've had decimals, now we have fractions. 5 equals x plus 2 1/3. Since my x is on this side, it's my only variable, I'll just keep the x over here. And I'll isolate it on this side, which is fine. So I will subtract 2/3 from both sides. 2 1/3, I mean. So minus 2 1/3, minus 2 1/3. that cancels out. So now I only have x on this side. I have 5 minus 2 and 1/3. I think I'll get a scrap paper. I'm going to write it this way, minus 2 and 1/3. And wouldn't you know, I have a fraction in my algebra and I have to regroup. If you have nothing here and you have to take 1/3, you've got to get some fractional parts. If you have 5 wholes, you definitely have plenty to spare. So I'm going to take these 5 wholes and I'm going to take one of them and then I'm going to break it into thirds. So now I have 4 wholes and 3/3. That still makes 5. See, I've got 1, 2, 3, 4 wholes and 3/3. See, it's still 5, so I didn't change the number. I just changed how it's grouped. So 3/3, take away 1/3 is 2/3. 4 take away 2 is 2. So now I have 2 and 2/3. That's my final answer. Since I have plenty of space and that's kind of small, what I'm going to do is I'm going to write it bigger. That way it's a lot more legible. It's easier to recognize that. It's kind of hard to tell that that's a 3 or a 5. I want to make sure it's very, very clear. I have a sharp point on this pencil, but it's not very precise, regardless. Number 8. 1 over negative 5d minus 1 equals 24. I've told you this before, but I could write this as 1, actually, let me just put this here. I meant to put it here. Okay, negative 1/5 d minus 1 equals 24. I could write it just like that if I wanted to. It's the same. Or I could write it negative d over 5 minus 1 equals 24. I can write it either of those ways. It still means the same thing. My preference is to write it that way, but often you'll find them this way. This is when you're writing slope-intercept form, when you have equations in slope-intercept form, they write it with a fraction in front of the variable. But it doesn't have to be. If you've got you can always put that variable, you can put it on top, because that's a whole and that's a whole. All right, so now, given that, what we'll do first is nothing with this. We'll keep that. That's our variable term. We have to get it by itself before we can do anything with it. So I will add 1 to both sides. That gives me 1 over negative 5d equals 24. When you have a fraction in algebra and you kind of wish that you didn't, because ultimately you need to get that d by itself, and having the fraction with the d complicates things. So the best way to simplify this, to make it a lot easier actually, is to lose the fraction. What I'll do is I'm going to multiply both sides by negative 5. When I multiply both sides by negative 5, I will no longer have a fraction. That's how I get to get rid of this fraction. So I'm going to multiply this side by negative 5 and this side by negative 5. The negative 5's cancel out, so I'm left with 1d. And since 1 is just understood in algebra, I'll just put d equals 24 times negative 5. Don't forget that was a negative 5. So it's going to be negative. That would be 120. I bet this is all clicking. You're just like, I get this. I understand what you're doing. This is awesome. I hope so. We'll move down to 9 and 10. We've got distributive property with 9 and with 10, but we've got a fraction that we're distributing. We've worked on distributing fractions in the distributive property book, but now we're doing it in a real equation, not just an expression. All right, so the first thing we've got to do here, thankfully we've got just a constant on the right side, so that's fine. We don't have to do anything with that. We need to deal with this side. The first thing we've got to do on this side is we'll go ahead and distribute. We actually have to distribute because we have a variable here and a variable in here. The only way to combine those variables is to distribute. So 4x, negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6 equals 21. The next thing I've got to do is combine my like terms. I've got two variable terms. That would be 4x minus 3x, so that leaves me with just x, 1x or x. Some people prefer, when they're solving algebraic equations, they prefer to put a 1 in front of it. It's fine if you want to do that. It's absolutely fine. Plus 6 equals 21. How nice. I will isolate just the variable term by subtracting 6 from both sides. That gives me x equals 21 minus 6 is 15. And since the variable term is just the variable and no other coefficient besides 1, I'm done. Number 10. 1/10 distributed among the x minus 40. I will put it all over x. So 1/10 times x is x over 10. X divided by 10. You could also put 1/10 times x. Whichever you prefer. I prefer to do 1/10. I want to do x over 10. Look here. 1/10 times x. 1/10 times x. I'll write it as two fractions. Equals 1 times x is x. 10 times 1 is 10. See how that works? So you see, it is truly x over 10. It's okay if you don't take my word for something and you want to explore it for yourself and see. It's always okay. In fact, I think that's a positive because you better understand it. And if you think critically and you have your little doubts and then you check to make sure, that's really good quality learning. And that's a good learning skill in life, not about just math, but about everything. Find out for yourself. You may trust me as your teacher, but guess what? I make mistakes. All right, so I'm going to do x over 10 because I prefer it that way. 1/10 times negative 40. Well, what's 1/10 of 40? It's 4, but let me show you. 1/10 times 40. 1/10 times 40 over 1. Ooh, look, you can cross reduce. Equals 4. See that? So since I went ahead and solved that, I'm not going to write 40 over 10. I'm just going to write minus 4. Remember the negative, it's because it's 1/10 times negative 40. When I did my computation, I just usually do my computations, just all positives. And then when I write my final answer, then I add whether or not it's positive or negative. 1/10, x over 10 minus 4 equals 26. My next step is to isolate my variable term. The opposite of minus 4 is plus 4. That was such a hard one. I had to think about it. I have x over 10 equals 30. now to isolate just the variable, I do the opposite of divide by 10. That is times 10. I have x equals 30 times 10 is 300. So that is the first column. We still have 3 more that I want to do in the middle column. So let's move over to the middle column, starting with 16. Yeah, I'm using my hard copy instead of my copies of it, and so that's why there's whiteout. I couldn't get these to neatly print with my computer, so I had to write it in afterwards, and of course my handwriting is terrible, so I had to erase it and rewrite it and erase it and rewrite it to finally get it legible to copy. So my copies don't have the whiteout on it, but I grabbed the original to teach from. So that's why it's got that. See, if I show you a copy, see my copies, you see, there's no whiteout on those. I did not mean to grab the original. But anyhow, disregard that. I wish that when I was teaching in video, my whiteout didn't show up. It just seems like it's exacerbated through the camera lens. All right, so number 16. I have a fraction with a variable in it. So the first thing I want to do is get rid of that divided by 4. Because I need to get rid of it. First thing. Right? No? I can't do that yet? Why not? This is kind of like my variable term right now. And I just need to not do anything to it at all until I first get rid of that. So we have to just leave it. I'm sorry, you can't do anything about it yet. You're just gonna leave it. So we're gonna rewrite it because we're leaving it. We're keeping it. For now we're keeping it. Because the first thing we're gonna do is get rid of the plus 7, minus 7. Now that's canceled out and we have n plus 32 divided by 4 equals 40. I am prepared to divide this into 2 sides. Now we can get rid of this divided by 4 and make it a much easier problem. There's not really a way you can get the n by itself as long as you have the divided by 4 here. So we will undo the divide by 4 by multiplying by 4. So that gives us n plus 32 equals 160. 40 times 4 is 160. Make sure my equal sign looks like an equal sign and not a negative. My next, you know what, I'm going to take this and write it up here. N plus 32 equals 160. Yeah, that's easier. So now I need to isolate the n. So I will subtract 32 from both sides. I have to subtract because if I add it, then it just makes it bigger. I don't want it bigger, I want it gone. So minus 32, so you're gone. That leaves me with n equals 160 minus 32. That requires regrouping. So this becomes a 10, this becomes a 5. 10 minus 2 is 8. 5 minus 3 is 2. 128. N equals 128. I kind of like these. You know, you take this complicated thing and you do one little thing to it and you make it easier. And you do another little thing and it makes it easier. And then another thing. And you just keep making it a little bit easier, one step at a time. And then you have nothing but the answer. I just think that's cool. It's like very organized and orderly. 17. We get fractions again. 4x plus 1. Okay, so the first thing I need to do is isolate this 4x. So we'll subtract 1 2/3 from both sides. That gives me 4x equals. So I'm going to get my scrap paper. I have 13 8/12 minus 1 and 2/3. I have different denominators, so I need to have like denominators. 3 goes in, okay, so I know. I'll keep them at 12, so this is going to stay 8/12. This becomes 12. 3 times 4, so 2 times 4. Oh, 8/12 minus 8/12 is 0/12. 13 minus 1 is 12. 12 and 0/12 is, well, 12. So 4x equals 12. Now this is super easy. Divide both sides by 4. And then my x equals 12 divided by 4, 3. Ain't that nice? 19. We've got distributive property with a minus in front of it. Do you remember how that works? What I like to do when I'm teaching this is I like to have people pretend like this is a -1, that you're distributing a -1. And that makes it seem a lot more obvious what you do. So let's go ahead and distribute the -1. So 9, so -1 times 8 is -8. -1 times positive n is -n equals 12. Take a peek down at number 30 on your page. That's the same kind of problem. Everything I'm doing with you, there is at least one other equation that is similar. Because I want you to do it with me, and I definitely want you to do it by yourself. I know sometimes we do lessons together, and I teach you how to do something, and then that particular one might not have one that you can practice on your own. So I made this specifically so everything that I do, you do as well on your own. So the next thing I need to do is combine my like terms. I've got 2 constants and a variable. I always like to do my variable first. It's -n. 9 minus 8 is 1, plus 1 equals 12. Now to isolate my -n, I subtract 1 from both sides. That leaves me with -n equals 12 minus 1, 11. If -n is 11, then positive n is -11. And I think we got this. We absolutely got this. I tell you what, look over at number 27. I might just sort of get you started on that. Oh boy, I don't like this whiteout on here. Already enough when I have whiteout because of my mistakes. This was mistakes because I had to rewrite them several times to make them neat enough to be able to copy so that it could be effective. All right, so the first thing that you want to do is isolate the 3/2 k. So you're going to subtract 3/2 from both sides. Then when you have, 3, you don't necessarily write this. I'm just going to give you an idea. When you have 3/2 k all by itself, when you get this on this side, you want to get rid of that 2 on the bottom. So you'll multiply by 2. When you do that, you'll end up with 3k. 3 times k. Just keep that in mind. That's the only other thing I want to go over with you. Other than that, I think you got it. Yay! This looks so fun.